Okay, so let's start then. So hello everyone, myself Anshik Srivastava, and today we are going to discuss two previous year questions for GATE Civil Engineering based on soil mechanics. So I have discussed like previous time. I have discussed here or mentioned here the topic that we are going to discuss. So if it is of interest to you, then you can stick around, and if you know this topic thoroughly, then you can proceed with something else. Okay, so we will discuss Atterberg limits and effective stress gate questions. But in Atterberg limits itself, there are a lot of questions that have been asked. So the additional questions that I will be discussing, they will be related to the void ratio, porosity, those kind of things. So, okay. So let's start. So the first question is from GATE 2008, question number 44. The relevant NPTEL course details have been given below. The liquid limit and plastic limit and shrinkage limit of cohesive soil satisfies which of this relation? So for this, let us try to recall the diagram of volume and water content. We all would have seen this diagram. So someone has already given the answer. Very good. So we all would have seen this diagram. So this is volume and this is water content in percentage. Let's say we have a wet soil with some water in it, and then we dry the soil. So this is the initial point of the soil, and then we keep on drying it and measuring the volume also. So we keep it in oven some time, then take out, measure the volume and water content and so on. So we'll get a curve like this. The volume will keep on decreasing with the water content till a point, till some point, and after that it becomes constant. So can you guys tell me what is this point called? What is the water content at this point called?
Shrinkage limits.
Yes, very good. This is called shrinkage limit. Then at some location after this shrinkage limit, we have our plastic limit. And then after some more distance, we get our liquid limit. Okay, so just a random question. Can anyone tell me which apparatus do we use to measure the liquid limit in our colleges?
Sir, it's Casa Grande.
Correct, because these type of questions are also asked. So for liquid limit, we use Casa Grande apparatus. And how many number of blows? So when it is just like a cup on on a stand. So the base has some specifications. This is a cup. It is like a cup, and we put our soil paste here, and we make a groove in it, in that wet soil. Yeah, very good. So Pragati understood my question and she has answered already, but still I'll ask my question that we make this groove, and as Pragati has said, and when we rotate, when we rotate this mechanism here, this cup moves 1 centimeter up and then falls down. Then again we keep on doing that, and then we plot the number of blows it took to close this groove and the water content corresponding to it. So we get something like this. Something number of blows will increase when the water content decreases. Yeah, so we get something like this. So we have some points here, and the water content corresponding to the 25 number of rotations or blows in which this groove closed is called as liquid limit. So that's for liquid limit. Now what about plastic limit? Plastic limit is actually very difficult to find. Even in my final year BTech, I worked on a project to to find out whether we can use fall cone method, which is also used to determine the liquid limit. So I worked on a project to determine if we can use the fall cone method to get the plastic limit, but it doesn't work all the time. So conventional method is you take soil, take a little bit less soil, some plastic soil, and then you try to roll it on a glass or acrylic sheet, and you see that if you are able to break the soil just at 3 mm diameter, if your soil cylinder or soil roll breaks just at 3 mm diameter, then you say that it is that particular water content is, you know, uh, plastic limit. If you can go finer than 3 mm without breaking this roll of soil, then we say that we have to reduce water content even more to get to the plastic limit. But this experiment, since we human perform this experiment, it is very ambiguous. We ourselves, if we perform this experiment, we'll get different value every time we do the experiment. So that's why it has been looked for whether we can actually identify some other method to get the plastic limit. Shrinkage limit. So shrinkage limit, nicely we can say a determination of shrinkage limit is a little bit complicated thing. You have to identify the volume through mercury and all. But if you want to understand shrinkage limit, it is simply, you can understand it using this diagram. So three-phase diagram. Have you all heard of three-phase diagram for soil? Who has not heard of three-phase diagram? Okay, so maybe you all have heard of three-phase diagram. So in the soil, we have solids, we have water, and we have air. So if you were to separate all these things and keep them in a stacked column, then we will have the three-phase diagram. That is, the soil will have solids, it will have water, and it will have air. So the voids will have water and air, and the solids will be Vs. Okay, so this is actually VA, this is actually VW. Now, when you perform this, let's say, so when we are doing this experiment, actually, we have a saturated soil. What does that mean? That means that all the void is filled with water. So we don't have anything, any space for air. So when we decrease the water content, this being the total volume, when we decrease the water content, this keeps on decreasing. So the volume keeps on decreasing. But after some amount of time, the water will go away. All the water will go away if you keep on drying the soil. But the volume will, sorry, but the volume will stop at a threshold. So even though this is the volume of the solids, we'll have some more volume. That is because if you look at the soil solids, how they are arranged like this. If you assume that soil solids are like a sphere for simplicity, they are arranged like this and they have empty space. So when you keep on drying them and when you reduce the volume, they become compact, but they cannot compact further beyond this point, because they are all making contact with each other. Beyond that, if you want to compact them, you have to break these molecules, break these soil grains, and then you have to do the proper compaction. So but we don't do that in our test. So we have some place that is still left where the solid is not present. And since we have heated now, this water also has escaped here. So now you know, the new kind of uh, we should say the new three-phase diagram, or now the two-phase diagram will be, we have solids here and we have air. So this is what we get if we keep on drying it. So after getting it out from oven, we actually don't stop. We don't know like we don't stop here. We stop here where the water content is zero. We have completely evaporated all the waters in the void. So this is actually with what the three-phase diagram is valid. But if you were to if someone is to ask you that we are drying the soil from the liquid limit and we stop at shrinkage limit, what will the phase diagram look like? You have to say that this will be solid and this will be water. Because one thing you have to remember, that even at shrinkage limit, the soil is saturated. All the voids, just at this point, the soil is saturated. All the voids are still filled with water, but only in these small voids that the grains cannot occupy, the water is available. Water is not anywhere else. It is not contributing to the volume of the uh, total soil. Just something that will be useful in our further questions. That's why I told these things. So just remember that we have this three-phase diagram, and I think it is fairly obvious that liquid limit, plastic limit, and shrinkage limit follow this kind of trend. So someone already had answered this. The answer will be B. Liquid limit is bigger than plastic limit, which is bigger than shrinkage limit. Okay. Also, some more things. I hate remembering formulas, guys, but actually we have to remember some of the formulas. So I will tell few of the formulas that might be useful. I don't remember which are the questions that I have kept in after these two gate questions for our discussion, but for maybe these formulas will be helpful. So what is plasticity index? Plasticity index is nothing but liquid limit minus plastic limit. What is liquidity index? Can anyone tell what is liquidity index? There is liquidity index, consistency index, and shrinkage index also is there. So shrinkage index and plasticity index are pretty similar. Like plasticity index is liquid limit minus plastic limit. Shrinkage index is plastic limit minus shrinkage limit. Now, these are actually fairly common questions that have been asked in GATE. So, can anyone tell me what is liquidity index? Okay, so liquidity index. So, uh, Sailaja has nicely dodged the question. So, when I was in, I remember this. The answer that Sailaja has given is very similar to that. Where is my home in front of your home? Where is your home in front of my home? So we don't want to give that kind of answers here. So liquidity index is the natural water content minus plastic limit divided by plasticity index. And we can use Selja's so I don't know if I'm pronouncing the name right. So if we can use the formula also, you can remember this also, or you can remember that it is consistency index is liquid limit minus natural water content divided by plasticity index. So these are most common, and also there is an activity which is plasticity index divided by percentage of soil grain less than 2 micrometer. So this is also something that this actually is associated with the swelling of the soil. I don't think we have any question at this moment related to activity, but just I just recall that there is this also has been asked 2-3 times in GATE, so you can use this. Okay, let's go to our next question that is related to effective stress. So GATE 2007, question number 80, the relevant NPTEL lecture has been cited. So this was a two-part question, but the second part was related to consolidation, which we will discuss in some other session in more detail, starting from the basics of consolidation. So I have not included that 81 part of the question. We are just going to discuss question number 80. The ground conditions at a site are shown in the figure. The water table at the site, which was initially at depth of 5 meters below the ground level, got permanently lowered at a depth of 15 meters below the ground level due to pumping of water over a few years. Assume the following. Unit weight of water is 10, so this makes our life easy. Unit weight of sand above the water table is 18, so maybe it is not the dry unit weight, but just the bulk unit weight of a little bit wet soil. Then unit weight of sand and clay below the water table is 20. So they have made our life easy. Even though there are two type of soils, they have given that the saturated unit weight of these both of these soils is 20. Coefficients of volume permeability, compressibility is 0.25. So we are not going to use that, just for your reference. So what is the change in effective stress in kilonewton per meter square at depth of the clay layer, at the mid depth of the clay layer due to the lowering of water table? Okay, before we go to this, let's say we have, so first we'll discuss what is actually effective stress. So let's say we have a soil layer. This is, and here we want to measure the effective stress, and the water in this soil layer is till this location. So if I were to draw my total stress diagram, that is the pressure due to the weight of water and soil per meter square above this area, it will be for here, for looking at this thing only, looking at the place above the water table, we have a simple triangle, and which is contributing only because of the soil, and then we have a little bit changed slope triangle. So let me just try to make a different slope. We have a little bit changed slope triangle. Now we have soil weight plus water. So this is the total stress diagram. What is the water stress diagram now? If I were to ask you, what is the contribution from only the water? So it will be, since from this depth, from this location to this location, there is no water. We are assuming that there is no water. So from here to here only, the water is going to contribute. So it is going to be a smaller triangle. Okay, I hope that you all know why this is coming as triangle. So actually, because of we will simplify this by, I don't know if, so if anyone doesn't know, then they can say now. Maybe I can try to simplify it. I can try to say why this is coming as triangle. So Ajay is saying no. So it means you don't know or you know. So maybe the question was not clear. If you don't know, say I don't know or say no. Yeah. Don't know, sir. Okay, okay. See Ajay and everyone. What is pressure? It is weight per unit area, right? So let's take, we have water in a cylindrical kind of jar with base area A. So it is uniform. The area is uniform. And we have water filled till the height h. And this is A area in the bottom also. So what is the weight of water? Weight of water is going to be density of water into gravity into the volume. Volume is area A into height. Is this clear? Okay. Now weight per unit area. So we have the area as A. So rho W, we have to divide. Now the pressure will be weight per unit area. It is rho G H. And this is only sometimes in soil mechanics we write it as gamma W H, where gamma W is nothing but rho G. Okay, so at any depth H, we have the pressure gamma H or rho GH. So if I was looking at this depth, that is H1, the pressure will be gamma W H1. And if I look at this depth, where it is H2 from the top, the pressure will be gamma W H3. So if we draw a line of pressure with our depth or height, we can say whatever we want to say, we can say here H. So it is a straight line and it is keeping on increasing with the depth by the slope gamma W. That is why it looks like a triangle. And we have just rotated this and plotted it here. Okay. So at this depth, now we talked about water here. We can easily replace this gamma W by gamma of soil. So for soil, if we look at this depth, let's say H from top, the pressure here is going to be gamma soil into H. And if we look at this depth, it is going to be, which is H2, let's say, maybe I will zoom it here, which is H2, the pressure here is going to be gamma S into H2. So the slope is constant and pressure keeps on increasing. And this distance or the base of the triangle at any point of time is going to tell us the pressure at that particular depth. Okay, good. It is clear now. So now what we should do, we should go to the question. So the question is, or maybe I will do it here only because there are so many variables. So it will take a lot of time to just copy paste them or draw them again. So the question is, what is going to be the increase in the effective stress, which when the water table is lowered from here to here. So what is effective stress? So as I said, we will have at the middle of the clay. Yeah. So we will have total stress, that is because of soil and water. So previously the water table was here. So let's draw the total stress diagram, because that also, yes, that also I think, I don't know where, but this kind of question has come, that what will be the, no, how will this effective stress diagram look like? And it is actually important when you go to the retaining wall section in the geotech. You will need to calculate the area of this triangle. So in that case, you will need to correctly draw the triangle. So this will be one slope of the triangle, which will be, oh, really sorry about this, yeah, which will be some, yeah, which will be given by the density of the soil, that is 20. This is the slope here. Now, sorry, density of the soil above the water table, right? So it will be 18. Now here, when the original case, the water table was at this location. So we have to use now the density or the unit weight of soil and clay below the water table. So we have to use 20. So now here you see the slope is changed. So I'm going to try to make a different slope. I always end up making the same slope. I don't know why, but just imagine that this is 20. Okay, so this was the total pressure, and the pressure from water was starting from the water table depth and going till here. And what will this be? Well, what will be the slope of this? It is going to be 10, because that is the unit weight of water we are given. So the difference of these two is going to be our effective stress. So we have starting only 18, and afterwards we are subtracting here something. So we don't know yet what will be the, no, we cannot just say the slope here. We'll just say this will be kind of our effective stress diagram. Sigma dash, we denote it by sigma dash. And when we have lowered the water table, then the effective stress diagram. So I want you guys to draw on your copy. So we'll keep this here. I want to keep this here. Maybe I will shrink it. I want to keep this here. So when we have reduced the water table, the total stress diagram will be something like this. For above the water table with slope 18, and then 20 till the middle of the clay layer. And the water, and the water pressure will be 10 throughout. So what is the difference between these two is going to give us the effective stress at this point. So this is our going to be second effective stress, and this is our going to be first effective stress. So what is the difference between these two? That is what the question is asking us. So let us calculate both the effective stress, both the effective stresses. Okay, so the first effective stress, the first total stress is going to be, let me write it as sigma 1 T, 5 into 18 plus, so this is the contribution from the soil above the water table, and from the middle of the clay layer to this location, how much depth we have? So we have 5 here, and this is 15, so this is 10, and this is whole as 20, so this is again 5, and this is 5, so this is 2.5 micron. So there are some numbers, if you look at it carefully, it will also make sense to you. So 17.5 into, what is the unit weight for sand and clay below the water table? It is 20. So this is our total pressure. But to get the effective pressure, we have to subtract the water pressure. So water is starting from this location and it is going till all the way. So we have to subtract 10 into, what is the depth? So we have 10, 5 and 2.5. So whatever the saturated depth we had, we have the same depth here, the 17.5. So the effective stress in first case is going to be 5 into 18, that is I think 90, plus 17.5 into 10, so 175, which is actually this thing. And what, okay, Shailin Hari has said 0. So the 0 question is also there, but we'll see. In this case, the answer is not 0 actually. So what is the total stress in the second case? So we have now the dry soil in this whole region, which is actually the full 15 meter, right? So we have 15 into 18 plus how much we have, how much wet soil we have? We have this 5 and then 2.5. So 7.5 into 20, and U2 is 7.5 into 10. So sigma 2, sigma 2 effective is going to be 15 into 18 minus 7.5. So what are we getting? 50. So we have our change in the effective stress as 80 Newton per kilonewton per meter square. Okay, good. Now let's go to other question. So yeah, in this question our Shailene Hari had a doubt. So you are actually we should say, yeah, I think you are correct, Shailene. So I think you are correct. If we were to take the effective stress here on the even on the top of the clay soil here, theoretically practically speaking, it should not change because the water table is above. So yeah, so one more question, one more thing we can try here is that we can see that if the change in the water table is above your section, above the section where you are calculating, then even if you go here or a little bit above also, if as long as you are below the new water table, the change in effective stress is going to be same. That was your question, Hari?
Yes, sir.
Yeah. Okay. So now let's go to the other question. So which one of the following phase diagram represents a clay at its shrinkage limit? So here again, see, as I said, whenever this kind of question comes, we have to remember that we are coming from the wet to the dry, and the clay is at its shrinkage limit. So the water content is corresponding to its shrinkage limit. Okay, very good, very good. So B is correct. Because why? Because at shrinkage limit is the minimum water content at which soil is saturated. And when soil is saturated, all the voids are filled with water instead of air. So we will have water and solid only. Okay, good. Okay, and now this question. So this question is very important when we are, we are preparing for gate and we are doing soil mechanics. This everyone should know the answer to this question. So I am going to just read out this question and I'm going to see what are the answers that you guys are going to give me. So void ratio, porosity, degree of saturation, water content. So we have to match what is the formula for corresponding things. Void ratio. So VV is volume of void, V is total volume, VW is volume of water, capital W is total weight, W subscript W is weight of water, W subscript S is weight of solids, and Vs is also volume of solids. So the answer is people are saying D D D. Let's see. Void ratio is volume of voids by volume of solids. So this will be 5. Porosity is volume of void by total volume. So this will be 1. Degree of saturation is volume of water upon volume of void. So this is 3. Water content is weight of water, weight of solids. This is 2. So 5132. Do we have an option? 5132. Correct. So, okay. So very good. So everyone has answered correctly. Whoever has answered, they have answered correctly. Okay, now let's go to this question. So I have mentioned the I think the formulas ahead. So let's try to use them now. Soil has liquid limit 35, plastic limit 20, shrinkage limit 10, and natural moisture content is 25. What will be the liquidity index? Okay, so someone has already answered, Pragati, as answer B. So let us all try to calculate. What is the first question? Liquidity index. As I said, liquidity index is natural water content minus plastic limit divided by plasticity index, which is nothing but liquid limit minus plastic limit. So we have 25 minus 20 divided by 15. 5 by 15, 1 by 3.33. So Pragati's answer seems to be correct. Okay, so everyone else also has answered, but still let's calculate. Plastic limit is again from here we get 15, and our shrinkage index. So do you guys remember the shrinkage index formula, or you guys said B because only these two are coming in this option? Okay, so I have told before also, I'll just repeat it. Shrinkage index is nothing but plastic limit minus shrinkage limit, that is 10. So the answer B is correct. Good. Now, uh, in this effective stress and in the soil characteristics, lot of times we are asked to calculate the gamma, the unit weight. So I want you guys to remember only three formulas using which you can calculate all these questions related to calculation of the unit weight. They are, first one, the dry unit weight, that is GS gamma W 1 plus E. GS is the specific gravity, gamma W is unit weight of water, 9.81 kilonewton per meter square, per meter cube actually, yeah. Then we have 1 plus E, where E is nothing but void ratio. This is first formula. Second is bulk unit weight. So in this case the water content is 0%. Second is bulk unit weight. When you want to when the soil is having some amount of water in it. So it will be GS gamma W 1 plus E into 1 plus W. So you might have also heard this formula G plus SE gamma W 1 plus E, but I think it is too complicated for me. So I will just not use remember this, and I would actually remember this, which simplifies to gamma D into 1 plus W actually. This is the second formula, and the third formula using which you can get all the other formulas, that is Sehwag. So I call this formula Sehwag. I also got to know about this formula from I don't know which person, but it is a very nice acronym to remember this formula. So we have Sehwag, one of the very great cricket players. So S is degree of saturation, E is void ratio, W is water content, and G is specific gravity. So if you remember these three formulas, you can solve any of the unit weight questions. Now we will try to get this from this and this. Let's do that. So we have been given a soil has a mass unit weight gamma. So it is nothing but the bulk unit weight, and water content is W, specific gravity is G, and unit weight is gamma W. So what is the degree of saturation? So let's write the formula for gamma. G gamma W 1 plus W divided by 1 plus E. Now what is E from our Sehwag? E is nothing but W capital G divided by S. So when we substitute it here, we get gamma is equal to, so let's directly substitute and bring it to the left hand side. So 1 plus Wg by S is equal to G gamma W 1 plus W. So gamma S plus WG is equal to SG gamma W 1 plus W. What we have done is just we have multiplied S on both the sides, LHS and RHS. So this will become S, and this S will get cancelled, and here also one more S will get. S is sewage. Shivam Sharan Lal. No, no, S is degree of saturation. Okay, so I don't know what Shivam wanted to say. Oh, okay, sewage is also okay. Very good. Shivam has also suggested one acronym, that is sewage. So yeah, even better related to civil engineering. Yeah, so you can use sewage also. Thanks, Shivam, for sharing an acronym with us. Yeah. So we have, when we open this, we get this, and we can further go on simplifying this. You take some things left and right, cancel out. So you will get S like this, and to get it into this format, you have to just divide everything by divide the numerator and denominator by G gamma. So you will get G. Oh, sorry, this G will go away. So this will be your expression. And let's see, do we have this in our options? So we have W on the top and 1 by G in the second portion of the denominator. So do we have W on the top and 1 by G in the second portion of our denominator? So B is correct. So does everyone understand how we got this? So you don't need to memorize these things. You can actually derive these things if you know just these minimum 3 number of formulas. Okay. Okay, so yeah, stemming from the first question, maybe I just realized something. Maybe in from this question, if I were to ask you, let me make another question and ask you what will be the answer. Let's say we have, uh, let's say we have a soil. So this is some soil depth X, and above that we have water. Let's say we have a lake. Yeah, we have a lake, and then we have a soil on the soil bed, and on top of that we have some water. If in the January, let's say the water level was this much above the soil level, and then in December it fell because of continuous use from the local population. It fell to this much level. What will be the change of in the effective stress in the middle of the soil layer? So this is something, no change. Okay, zero. Okay, so we have two responses. Anyone else? Okay, so we have zero, and that is correct. So I leave you guys to think about it, why that is actually the case, but it is pretty simple. The Yeah, I want you guys to think about it. Just I have given one hint. Like these kind of questions actually have stopped coming now because everyone knows the answer is zero. But still, if some of you don't know, then you have time now to think about it. We have some other expression. So picnometer is used to measure what? This is also one of the in the match the following kind of things. This kind of question can come. Picnometer is used for what? Why do we use plate load test? Specific gravity. Very good. Sarja has said specific gravity, and that is the right answer. Now, if you are the formula remembering kind of person, you will directly, yes, you will directly remember this, and you can say that it is D. But do you guys want me to derive this, how this came actually? Can answer with the numerator itself, sir. Very good. Yeah, you can use option elimination and answer it. So, what is specific gravity actually? Let's just talk about this. What is specific gravity? Specific gravity is nothing but weight of solid divided by weight of water for that volume of solid. This is specific gravity. So as you know, Ajay has said, you can answer this by numerator itself. Why we can do that is pygnometer plus dry weight and the pygnometer weight. When you subtract this, you are going to get the weight of solid. So he has seen the numerator and he has given us the answer. Okay, but what if, you know, Ajay, I were to give you this option? Then you will be confused, right? Then we have to check the denominator also. Yes. Okay, probably then what I will do is I will tell you guys the trick to remember this thing. This is actually the easiest format to remember this equation. You just have W1 minus W2. You go from serial order 1, 2. And then you have W1 minus W2 plus W3 minus W4. So 1, 2, 3, 4. Minus, plus, minus. So this is one of the easier ways to remember this formula. Right? Maybe I can keep a separate recording for the derivation. Okay, but just see. This is one of the easier ways using which you can remember this. So 1, 2, 3, 4. Minus, plus, minus. Okay. And if you just multiply with minus sign on both the numerator and the denominator, you will see that actually it is the same as the answer that is given here. Okay, now we'll go to the last question for today. Probably this is the last question. Natural water content of soil sample was found to be 40%. Specific gravity 2.7. Void ratio is 1.2. Then the degree of saturation is what? So who can tell? Probably this is just a simple question. I should have taken, yeah, I should have taken a different question. This is just sewage or Sehwag question. You will get your S from this. Yeah, you'll get 90%. So yeah, so Hari and Ajay has answered correctly 90%. Now you can ask me some doubts if you have now, because I have exhausted all the questions. Probably we'll come again sometime back to this soil mechanics. Then I will have some more interesting questions. This time I actually randomly picked some questions, and these questions ended up being formula based. We'll have some more conceptual questions next time. Yeah, when we have effective stress and all, we will cover those things. Yeah, if you guys have any doubt, you can ask now. Okay, very good. So this was actually fairly simple topic, so I'm not surprised that you don't have any doubt. Very good then. Thank you for your help for the second question, and we'll meet again next week. Vijay, you want to ask some question? Okay. Okay. Thank you, guys. Yeah. 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 Oh, yeah. You can have the recording. Actually, the last week recording, I used a different software for recording, so the video editor was not supporting it. So I was not able to share that recording. Just give me 1 or 2 days more. I will record it again, or I'll try to recover that recorded video and I'll post it. I didn't get time to do that last week. This week I'll try that. Sorry about that. Yeah, I will upload that recording in that YouTube video. Thanks, guys. Yeah, have a the weekend is already over. Have a nice week then.